Hello everyone, my name is Shuai Huang. It's a great honor to introduce our work here named Context De-confounded Emotion Recognition. Despite the impressive advances of KL methods, we found that a context bias in existing datasets leads to an unbalanced distribution of emotional states among different contexts. Such biases mislead models to learning the spurious correlation between context-specific features and label semantics, causing performance bottlenecks. To tackle the issue, we summarize the causal relationships among variables through the structure-causal model from the causal interference perspective. We identify the adverse bias as a confounder and seek the average causal effect from an approximately confounded dictionary. In this case, a plug-in contextual causal intervention (CVPR2023) module is proposed to remove the harmful impact of such biases and provide consistent improvement to most methods. Let's start with context-aware emotion recognition, referred to as CARE. CARE is a challenge task that aims to perceive the emotional states of the target person with the assistance of context information. Previous methods have improved by exploring diverse context streams, such as background, scene, and social dynamic contexts. However, they suffer from a context biases of datasets, which has long been overlooked. For example, most of the images in training data contain vegetated scenes with positive emotions, while negative emotions in similar contexts are almost non-existent. Therefore, the baseline is misled into learning spurious correlations between specific contexts and emotion categories, giving wrong results in the testing phase. We also perform a toy experiment while analyzing correlations between scene contexts and emotion categories such as anger and happy. We found that more scene categories with the zero conditional entropy are most likely to suggest the significant context biases in the dataset, as it shows the presence of these scenes only in the positive or negative set of emotions. Motivated by the above observation, we attempt to rescue existing models by embracing causal inference rather than beating them. We first introduce a tailored causal phrase to summarize the CARE framework. The positive effects of context and subject features providing variable semantics follow the causal path from X to C S to Y, which we aim to achieve. Unfortunately, the confounder Z causes the negative effect of misleading the models to focus on spurious correlation instead of pure causal relationships. The adverse effect follows the backdoor path between X and Y. To address the confounding effect caused by Z, in the traditional likelihood, we stratify Z based on the backdoor adjustment to achieve causal intervention dual operator. Specifically, we seek the effect of stratified context and then estimate the average causal effect by computing a weighted average based on the proportion of samples containing different context products in the training data. The intervention forces X to incorporate every Z value into the predictions Y, subject to the proportion of each Z in the whole. Since the number of contexts is large in the real world and there is no ground truth context information in the training set, we approximate it as a stratified confounded dictionary. After that, we approximate the above expectations at the feature level and parameterize a network model to approximate the above conditional probability. The overall process described above constitutes of the proposed plug-in contextual causal intervention module called CCRM. Our experiments are conducted on 3 datasets for the CARE task, namely emotic, CARES, and group work. We select 4 representative models to evaluate the effectiveness of CCRM, which have different context mechanics. zones. For the emotic, the CCIM-based models outperforms the winning methods by large margins, especially on some emotions that are heavily distributed by the confounder, such as anticipation and sympathy. For the chaos and group work, the performance of previous methods is consistently increased by CCIM, making each context prototype contributes fairly to the emotion classification. We then verify the effectiveness of the causal intervention by selecting two methods to perform thorough bet-on studies. We first show the rationality of the de-confounded dictionary by designing the random dictionary and replacing pre-trained models. Then, we found that CCIM does not rely on well-chosen pre-trained backbones, as the gain increases as the advanced backbones are used. Furthermore, we show that each proposed component contributes to implementing our effective causal intervention. Finally, we verify the necessity of masking subjects when constructing the confounded dictionary to visually show the difference between the model's approximate likelihood and information. We visualize the distribution of context features learned by models in testing samples on the group work. In the CCIM-based models, context perceive features from clusters containing diverse emotion categories. The findings suggest that the causal intervention promotes models to fairly incorporate each context prototype semantics when predicting emotions, alleviating the effect of harmful context bias. Moreover, we select two examples from each dataset to show the model's performance before and after the intervention. For instance, in the first row, the vanilla baseline is misled to predict entirely wrong results because the subjects in the DIN scene are mostly annotated with negative emotions. Thanks to the causal intervention, CCIM corrects the biases in the model's prediction. To summarize, our causal de-biases strategy effectively mitigates the harmful biases of uneven distribution of emotional states across diverse contexts in the care task. We believe that the model agnostic and lightweight CCIM provides better insights for the community than the complex module stacking in previous care methods. This is the end of my presentation, and thank you for your listening.